This is our last lesson of the unit, and we're going to be looking at 3x3 systems, which are basically systems with 3 variables. And because we have 3 variables or 3 things to find to answer the question, we need 3 equations to solve. Now the nice thing is we can use that process of elimination in these equations because the x's, the y's, and the z's in this case will be lined up so that we can manipulate the equations to create opposites so we can add them together and eliminate things. Now there's a pretty set process for these because as things get bigger we have to be super organized because there's lots of rooms for silly little calculation mistakes. So the first thing I do is I number the 3 equations I'm given. So if you can take a glance at our equations, they all have x's, y's, and z's. They're basically 3 things that have to be true so that we can find the values of the variables. Now, the first step, and you look, we have basic steps. It says choose a pair of equations. Manipulate the equations if necessary so you can add them together to eliminate a variable, creating a new equation, equation 4. Now, if I look through my equations, I actually have 2 equations where there's a variable there it's already set up as opposites. So if I look here in equation 1 and 3, I already have a y and a negative y. So usually we look for what's the most easy, and y seems like the easiest thing to eliminate. So I'm actually going to label it, this is step A from my steps up here, and I'm just going to write those equations. Now I find it helpful because mistakes do happen to just write what equations we're working with as we go through. So this is equation 1 and equation 3. So we're going to add those equations together. That gives me 9x. These 2 are eliminated. And we have minus 10z equals negative 25 in this case. Now that's a new equation, so I'm actually going to label that equation 4. Okay, so it's another true equation in our process. So now we're going to look at the next step. We're going to choose a different pair of those original equations. We're going to manipulate the equations if necessary, so you can add them together to eliminate the same variable. Okay, so we can't say, now I'd like to eliminate z, because then my equation 4 and my new equation 5 won't be able to work together. So I have to eliminate y again. Looking at these, and there's no, you have to do this one, but I kind of try to look for the easiest thing, the thing that's going to be least likely for me to make a silly mistake. And that looks like combining equations 2 and 3, because even though they're not the same number on y, I have a 4y and a negative y, the signs are already correct. So I would just need to multiply equation 3 by positive 4, creating a negative 4y. So I'm going to write them down. Now, this might seem like it's a little extra work, but I'm actually going to show that multiplication just because, as I said, there's a lot of room for error. So in equation 3, I'm multiplying the equation by 4. And I just want to get a different color. So 4 times 5x minus y minus 7z equals negative 19. Now I use these arrows to show I'm going to go over. And I'm going to rewrite both equations. So even though equation 2 is not changing, I want to have everything nicely lined up. So just recopying that equation. And then I have my new equation 4, which new equation 3, I multiplied by 4. So that's going to be 20x, right, if we distribute, minus 4y, there's my eliminating step, minus 28z. And then 4 times negative 19 is negative 76. So now I'm going to add these 2 together. So that's going to give me 18x, y's cancel, minus 26z equals negative 38. So this is equation 5. Now, in this process, I honestly think that's the trickiest part. Making sure I do everything correctly there. Now, if we look up at step C in our directions, it says equation 4 and equation 5 should both contain the same 2 variables, and they do right now. I have an x and a z. We're going to manipulate this pair of equations if necessary, so you can add them together to eliminate one of the remaining two variables and then solve for the remaining variable. So down here we'll do step C. So I'm going to bring in equation 4, which is 9x minus 10z equals negative 25, and I'm also going to bring in equation 5, which is 18x minus 26z equals negative 38. So looking at this, the easiest way to manipulate these equations is to multiply equation 4 by negative 2, which will create a negative 18x. So that's what I'm going to do. I'm going to multiply this equation by negative 2. I didn't leave myself great spacing, but I think it's still fine, and then we're going to distribute. So this is going to give me negative 18x plus 20z equals 50. And then we'll rewrite this equation. So we're basically just sending these equations across. So this is positive 18x minus 26z equals negative 38. So now we're ready to add, and we will be eliminating a variable here. So this cancels, right? And we have negative 6z equals 12. So now we're actually ready to solve for something. So here to solve for z, I just divide by negative 6. And I get z equals negative 2. So that's the first answer, and I think of everything as kind of being downhill from here, because basically once we get one thing, it's just some plugins to get the other two. So I'm going to come up here to do step D, just so we can kind of see the steps. I should be able to fit everything. So it says step D is plug the value of the variable you found in step C. So that's my z equals negative 2 into either equation 4 or equation 5. Solve for the remaining variable. So equation 4 and equation 5 just have an x and a z, so they can be solved for x now. So I'm just going to pick equation 4. I'll write my step. I put that one up here just to make sure we have room. So equation 4, and I'm going to write the whole thing just to make sure we understand for the first one, is this. So I just got that from equation 4, which I created in step A. So I'm going to plug in that negative 2 for the z that I just found. So I have 9x minus 10 times negative 2 equals negative 25. And then we just solve a simple linear equation. So I'm going to subtract 20 and get 9x equals negative 45. Divide by 9, and I get x equals negative 5. So there's my second answer. Now I was hoping to kind of fit everything in here a little more nicely, which I have on my written page, but now I have a step E, and because I don't want to remake the video, I'm just going to squeeze it in here. So I'm first just going to kind of section off and create a spot for step E, and that's why kind of using those letters, even if it seems like extra work, helps, because it takes up a lot of room, and then if you had to go back through, you can see your order. So actually, why don't we just section this off so we can see the different steps? Okay, so here's step E. It says plug the values of the variables you found in C and D, so z equals negative 2, x equals negative 5, into one of the first three equations. So all the equations look pretty similar. I'm going to choose equation 1, and I'll just write it down. So 4x plus y minus 3z equals negative 6. So I have 4 times negative 5 plus y minus 3 times negative 2 equals negative 6. So I have a negative 20 plus 6, so that gives me negative 14 plus y equals negative 6. And if I add 14 to both sides, I get y equals 8. So now, remember, we had a 3-part question. We needed to find x, y, and z, and we have done that. We'll write our final answer at the bottom. So this is negative 5, 8, negative 2. So this is a 3-coordinate point, has 3 coordinates, x, y, and z. If we were going to graph it, it would actually be on a 3D graph, so we'd have another axis kind of with our main two that fit on a paper, we'd have a third one kind of slicing right through the middle, and it would create a 3D space. If we were going to graph these, basically these lines, these three would be lines in that 3D space that intersect at one point in the 3D space.